Now what you're going to do in exercise 9A is you're going to be given the worded description or the locus statement, giving the geometrical description of the set of points, and from that you're going to form the equation so that we can actually identify exactly what shape this is. So you know that your equations for straight lines are generally in the form y equals mx plus b or ax plus by plus c is equal to 0. Your special straight lines are x is equal to a constant, y is equal to a constant, and that's about it for straight lines. You know, for parabolas you've got ax squared plus by plus c is equal to y, and you know your cubics, etc. A circle, x squared plus y squared is equals r squared. Now, like I said, in exercise 9A, you're going to be given the worded description and work with some whatever you're given in that worded description, in terms of you might the description might involve talking about distance. So if it's talking about distance, obviously you will need to use the distance formula. They might talk about gradient, and we will revise that. Perpendicular lines, we'll revise that. Perpendicular distance from a point to a line, that may come up in the actual worded description. And once we've got these formulas, like I said, we're going to work with them and hopefully produce an equation that we're familiar with. Now, just remember that this locus description is just another way of representing a relationship, and you know that relationships can be expressed as in an equation, in a table of values, or in a graph. And now a relationship can be described geometrically or more formally, and that's referred to as the locus. So for us to get from the worded description to an equation, we will rely on the words, and some of those words that we'll be paying particular attention to might be, the worded description might contain the word distance. So we know a formula for distance. So if it's telling us about a distance between some points, then we know the distance it can be represented between 2 points using this formula. Now, it's only a small thing, and this is probably the only place we do this, but you know that in our formulas we rarely have a square root. So what we will do generally is we will square the both sides of our statement so that we remove the square root. So instead of, although the statement won't say this distance squared is equal to something, it'll just say the distance is equal. We will, in our working, square to remove the square root sign. Some other things to be aware of: if you read a description and you recognise it as, for example, a circle, you read the description, it's saying a set of points such that they're all equidistant from a given point, and the distance is given as well, you can write the formula straight down. So you can sometimes go straight from the worded description with no working straight through to the equation. Because some of the workings will result in the equation for a circle, you know that the circle is of this format here, then there'll be workings where we might need to complete the square in order to get it looking more like a circle. So be aware of that. We'll be completing the square. These are all previously learnt concepts and techniques. All I'm doing here is revising things you already know, but it's just a bit of a refresher because this is what could come up in this first exercise. The worded description might mention gradient, and so you'll use the gradient formula between 2 points. It may talk about perpendicular, so you could use either this format or this format for perpendicular, where M1 and M2 are the gradients of the lines. It might talk about perpendicular distance from a point to a line. So if our understanding is the point is X and Y and we've got an equation of a line, then we've got this calculation for the distance. And in some of our workings, we might need to expand the bracket, and as recent as the last topic test, there are some students still being a little bit careless with expanding a perfect square. So we always need to be reminded about the correct way to do that. Square the first, twice the product of the two, square the last. Okay, so let's get looking at going from the locus description to an equation. Now, you can see that I've categorised these into one, very simple loci and harder loci, and that's just the plural for locus. And with these very simple ones, this is where we can actually, without any working, we can write down the equation. So let's have a look at it. Maybe we'll do a simple sketch, and then from the sketch, we can write the equation. Just be careful, there'll be times when a sketch is too difficult, and I personally find sometimes the sketching is not very helpful, so I don't ever spend too much time on it. If I'm not getting it, then I move away from it pretty quickly and I go into my algebraic method for getting the equation. It says, find the equation of the locus of points whose distance from the y-axis is 3 units. So this is one that I could sketch. So this is my x-axis, this is my y-axis. I want the equation of the locus of points whose distance from the y-axis is 3. So we all know this is the y-axis, and to go 3 units away, if that's 3, then I could be here. But this is also 3 units, and so is this, and so is this. So this is now a set of points, but I'd also have I could have the point here because that's also 3 units away. And so we get these 2 lines. They're straight lines, they're special straight lines, and we would write the equation for those 2 lines in the format x equals, because they're vertical lines, plus or minus 3. So no algebraic working to get that or convert that locus description into an equation, and we can understand that or interpret that locus as representing vertical straight lines. Again, I think I'll stop the video there because I really want to talk you through the algebraic method, which is, I've put here under the heading harder loci, and I want to make sure that I don't rush through that, but if the video is getting towards it's 9 minutes long, then I'm possibly run out of time.